The audience is currently using any form of cloud service. There's quite a few there. And out of all those people who are currently using it or might be using it in the next 18 months, how many people have actually done the full total cost of ownership analysis on this? 2, 3. It's always interesting to know, so at least there are some active users of the cloud already in there. The actual title of this session was actually Next Generation IT Infrastructure for Research. We've got the nice Slido coming up here, which has got a number of questions that have been raised by the community. If you do have questions that you also want to raise to the panel, please let us know. You don't have to use the technology. We do have good old-fashioned people in the audience with microphones. In the interest of time, we've got half an hour for this session, and there's already 14 questions, so there's more questions than we can physically cover. What I'd like to ask the panel is if I can ask the question and then maybe nominate one of you as the lead to do the answer rather than asking each of you in turn to answer it, because we'll probably get 5 repetitive answers or maybe a bit of conflict. But then once the lead person's answered it, any discussion, and then if anyone's got any questions in the audience, and we'll try and move on that way if that's convenient. So a nice easy starter for 10, which I'm sure everyone has already predicted, is combining sort of the top question here, which is basically, historically, there's been a lot of obstacles prohibiting particularly HPC uptake into the cloud. This includes costs, security, data locality, where's the support, where's the training, and this one's obviously looking very much at how safe and secure is my data. So in the panel's opinion, how is the best way that they're going to address this, particularly from a data security viewpoint? And if I could maybe ask Ian to take the lead with your understanding of ISO accreditations, etc., I'd like to hand over to yourself.
I mean, in some senses, the problem is no different for these sorts of cloud configurations that are being discussed today than for any other university research computing, because we're talking about data which is being stored either on the premises at this university or, in the case of the architectures that Simon's been working on, stored on the premises in other universities. So there isn't really a new problem there. Those issues would be much more substantial if we were talking, and I think there was another question perhaps coming up later on, which is whether this could be done with simply commercial off-the-shelf cloud architectures being bought in from third parties. Then you do have substantial problems. I mean, particularly then if you're talking about doing research work on data which has locality issues, which has to remain within the EU, or perhaps in this glorious new future has to remain within the UK, then that's obviously much harder to guarantee in commercial environments. But I believe that Simon here would be able to put his hand on his heart, and he wouldn't be able to point to the actual shelf of disks in which your data is held, but he would be able to point to the rack of disks within which it's held. And therefore, I think those security problems are somewhat overstated.
So I think there's an interesting point there is that as an infrastructure, we're building an infrastructure. How do we, so you want to have VMs where you get control over everything in the system. How do we provide data securely into that VM? The traditional way, so GPFS is great, it's a parallel file system. NFS, works for some things, it's got its drawbacks, but they're all premised on the users not having root in their systems. So actually, it's one of the big things that we struggle with, and we had a workshop with Dean yesterday about how are we going to address some of these things. And so some of the work that Dean was presenting on containers, we can actually, potentially in the future, we can very much restrict access and methods through. But in the kind of short term, it'll be, if you have full root on those systems, we can't give you full access to all of the data. Now, what we will do is, if we have a modicum of control of the VM, and maybe you're just installing software, then there's a different debate there for us to have, a different discussion about providing you access to the data. But absolutely, your data's in our data center. We guarantee it's on replicated storage, backed up storage, and we push it to tape. We have encrypted tape systems. We can reproduce it across data centers, so it's much more secure than that USB stick under your desk. Or I mean, I've soldered a USB stick back together for someone before in the past. So bringing your data to us is a much more secure environment.
I think that there's been the oft-stated comment that those of you in the proper grown-up sciences, you advance by learning from people who have done work in your field before. Our problem in computer science is we spend an awful lot of time forgetting the past and then stamping on people's fingers. The issues of storage that Simon points out about whether or not people have administrative rights to machines in clusters and so on, these were huge issues in the 1990s. I mean, I spent most of the 1990s working in storage consolidation. And my background's not academic. I've spent most of my career in industry. And we had solutions to those. And then some of the solutions which we advanced were moved into containerization when it starts in the mid-2000s with the work that comes in with Solaris 10 in particular. And we seem to be reinventing the problems rather than reinventing the solutions. I mean, the issue about whether or not you are root. I mean, I wrote a vitriolic chapter in my thesis, which caused my external examiners some grief when, going on about the fact that we mostly, a lot of our security models are about assuming computers are big, heavy things you can't carry around and that NEDs can't afford, whereas now your opponents actually have laptops. And the model has to change, I think, in order to support that. I don't think it's a debate for this particular meeting, but we in IT do, I think, a very bad job of reacting to essentially bring your own device.
Yeah, I think it's fair to say we've had similar experiences that if your data is on a local system, as Simon was saying, you've got more control. We do things like keep your own disks if something fails, so you're responsible for the failure. I think there's still a big issue about the data locality and data provenance if it's on cloud systems. That is a challenge that I think we still need to address properly, especially when we're starting to go on to some of the medical data and research that's on those sides. But I think, as you say, that's a challenge that we've got coming forward. So moving on, this is going down to the third question in the list, looking at the virtual machines. And actually, there's a slightly more generic question than how it's put there, I think, to try and capture some of the other areas is, does the panel believe that cloud can support high throughput computing as well as traditional high performance computing, particularly when you're looking at things like virtualizations? Because sometimes the tightly coupled applications do get quite a bit of latency and overheads on there, and are the current cloud services mature enough to support these? And if you think they are, how do we start scaling these out to tackle some of the bigger challenges? And I think, shall we look at sort of from a researcher perspective, so maybe Johan to say what you think on this side first of all?
Would you be as kind as to rephrase that to one single question?
Well, okay, so do you think the current cloud services are capable of doing both the high throughput or the serial jobs as well as the traditional high performance computing tively coupled MPI jobs?
Oh yes, I think so. And I'm very enthusiastic about the cloud because HPC has a very specific function, but there's a whole lot you can do with the cloud that isn't strictly HPC. So a lot of, I'm from Cal, from the humanities, a lot of our researchers do some programming, but when they do it, they don't necessarily do it in an HPC way. They don't necessarily use the full potential of the cluster. So in that perspective, I think it is actually really interesting to have a cloud, which I think the overhead in terms of throughput, like of the actual data, the access, the CPU, I think the overhead is very limited. So I don't think we're going to suffer that much. So I think we'll be getting the best of both worlds.
That's good for the sort of serial high throughput, but maybe Toni, your experience with Edinburgh and EPCC and Archer, how do you think that workload would migrate to the cloud if suddenly we needed to go there?
So I think tightly coupled HPC at the moment is not suitable for the cloud. Whether the cloud will evolve to become suitable, I think is an interesting question, because I think the way forward for computing as a whole is actually for a very diverse set of resources. So I think perhaps moving the cloud in the direction of something that can do HPC is not a good solution. It could go there easily. But I think there's a whole breadth of applications, and something that we do see with Archer is, I think there are applications that are using HPC on Archer that should be on the cloud, and then probably vice versa. So I think at the moment, no. I think in the future there is a potential. Whether that's the right future is a point to be debated.
So is this a piece of work that, as a panel, do you think there should be a bit more understanding of the types of workloads that are going on in existing local resources and what's being proposed through in terms of how we best match the applications to the resources available? A bit across the landscape that Susan was describing earlier, we've got a range of different systems under the e-infrastructure banner. How do we start targeting these most effectively? And maybe, Jean-Baptiste, I haven't given you a chance to speak.
Yeah, I completely agree. And in my brief presentation earlier, I put the bare cloud at the center of everything we do. And the reason I'm so happy and to blame, as I said earlier, for the chaos of the backlog, is we need this flexibility, this diversity of application in the field of bioinformatics. And I come from maths. I used to do fluid dynamics. We use a big HPC. We can have a big need for a lot of computing at the same time, but the same person at the different part of the project will need a virtual machine, high memory or low memory, doesn't matter. We have massive diversity. And what Simon has managed to devise is here for us, and I've got a lot of hopes for this new system, is to be able to provide both at the same time. So I'm more optimistic than you, maybe because I know less of the technology, but I think as a user, I'm really looking forward to this ability to be flexible on the type of applications we have and the diversity of things.
So I saw Martin with his hand up. I know Martin has views on cloud, and did you want to comment? And,
You've given away the last half hour of the session now.
That's all right, we can go. So I think it maybe depends on if we're talking about public cloud as well, and clouds which are dedicated for research purposes.
I think cloud, in the nebulous term of this, could be Amazon, Azure. Yeah. It could be not just locally provided, it should be the commercial.
I would agree that, you know,
yeah.
certainly in commercial cloud, public cloud, that I think there's a very difference to what we can do in a private cloud where we have control over the total technology stack.
And I think also, I think to some extent I would question the premise underlying some parts of this question, is that we have a tendency to slip into fairly easy abstractions which are not relevant to a very large range of problems. So the often stated thing is, oh, there's an overhead to virtualization. Well, for some workloads, yes, there is. For very, very intensively I/O-bound, very interactive workloads, there is potentially some overhead. On the other hand, if what you're doing is a massively computationally bound task, then virtualization has essentially no overhead. And there are also virtualization systems being constructed for very, very diverse systems. So the Mirage OS initiative at Cambridge, for example, is talking about thousands of instances on a single processor. And clearly, were there substantial overhead, that simply wouldn't work. So you have to be very careful about casual phrases like, oh, the overhead of virtualization. Because I'm sufficiently old enough to remember when similar things were said about time sharing. You know, and people would say, oh, it's terrible, we're wasting all this computing resource by not using a cafeteria service with punch cards. And no one seriously advances that argument anymore and says it would be more an efficient use of mill time if we return to using punch card batch processing. So you have to be very careful about these sorts of
I think there's very subtle nuances in how you use terms, but I think there's also a big risk that when you refer to the cloud, it depends on who you're talking to. And when you go into sort of like your university senior management, why can't you outsource everything to the cloud? And it's making sure, I think we've got the evidence and justification as to where the workloads are best suited. But over to Martin on the performance side.
Working?
Yeah,
hello?
yeah,
Can everybody? Yeah, you can. Okay, so this is quite quantitative. 70%-ish of the workload on Archer is in the area of material simulation. So there's half a dozen codes there. Quantum Espresso, VASP, CASTEP. They all depend on collective operations, and typically they all are governed by the latency of the interconnect. If you roll out on a cloud service such as Microsoft Azure, and we've done this, and you measure the scalability, it is appalling, right? Because IB over RDMA cannot support low latency collective operations. Now, that is today's current state of the play. It's not suitable for 70% of the workload on Archer. Tomorrow, who knows? If you can crack that IB over RDMA problem and you really can respond to low latency collective operations dominating a calculation, then you cracked it. But today, I don't believe you can.
So in the cloud that we're putting in, we have, we've not done the benchmarking yet to run SRIOV and InfiniBand, and then we have Switch IB2. So we heard you're all talking earlier on about, collective offload in the switches. So I think there are things we can do to help, tackle some of those issues. Now, I'm not saying that would work in public cloud. That's a very different infrastructure.
Sure. Well, I think, Microsoft or Azure claimed that this was not a problem. We gave them the application, we gave them the code, we gave them everything else, and they've never come back. So I believe it genuinely is still a problem, and if you've cracked it, that's great. But I still think today it's an issue.
So moving on, because obviously time is definitely against us, and I appreciate there's a drinks at reception waiting after this session. I think the actual support question is quite an interesting one that's been raised on the board above. And this goes slightly broader than maybe just for the Birmingham cloud, but I think there needs to be a strong alignment between computer science and the actual running of HPC systems, and there's a disconnect at the moment. And how does the panel see that disconnect of what the computer science are doing, being able to translate into the cloud or onto HPC services to lower some of these entry barriers that we've seen for people being able to exploit them? And the second side to the question is not just what we're doing in the universities, but as we've got some esteemed vendors sponsoring this, what do you think the supplier's role should be, if any, in this? Where is their expertise going to be in sort of helping get these workloads transitioned? And I will leave that one open. Toni, would you like to start on that one?
So there is a constant struggle, I would say, to get non-computer scientists to engage with HPC. So I'm coming very much from an HPC background. I will admit that my knowledge of the cloud is minimal at best. But yeah, we struggle. And more importantly, we struggle to get the non-traditional HPC users to use HPC. But even when we do have people on Archer, we've heard FASP and CASTEP being mentioned multiple times. What we now struggle with is the computer scientists and the vendors making these bigger and bigger machines, which I think is fantastic. But we're not getting VASP and CASTEP coders to make their algorithms scale better. That's partly because that's actually, I think, the single biggest challenge. It's not the hardware side. I think actually the algorithms are harder to scale than the hardware, which is saying something when we're talking about using so much energy. You need dedicated power stations for them. But we have this complete disconnect over the whole HPC and presumably the cloud community of the hardware people, the software people, and then the users and the actual scientists who come up with the algorithms. And we don't talk particularly well because at the moment we're not talking the same language. I don't know what the language is that we need to develop to do that, but we do need some way of bringing everybody into the room and having that conversation.
Perhaps Jean-Baptiste and Johan can say from a researcher perspective, when you were first coming into the field of using these facilities, what would be the easiest route in through the training that you'd have liked to have seen either from the service providers or from the suppliers?
I mean, change slightly the question, also a slightly different question. Is following up what Toni said is, as bioinformaticians, we write software very badly, and we do it very quickly because we are competing, we try to process a lot of data. And there's a lot of software which is very inefficient and not fitting at all the hardware or anything at all in all the different levels. So that's very bad. And that's been a problem for a long time. However, just in the last few months or years, it's been recognized to be a problem. And we are learning how to reprogram. We're starting a group here as well. We are learning to program better, to be better programmers, to have better computer scientists, to be more efficient with the work that we are doing.
Will that stay within your research group in Birmingham, or will that be generally available to services on the Bear?
So, for example, Microsoft has been trying to reprogram most of the big, heavy routines. The same goes with in the US. The big players are trying to reprogram the big routines to adapt to the proper HPC solutions and so on. So that's a move that's just very, very recent at the moment.
Yeah, I agree. And I think it might be important of starting to think as researchers, as end users of a product. So what we are talking about here today is very infrastructure based. But I think we probably should do two things with infrastructure for researchers and for their purposes. And the first is to make it more visible. And the second is to make it less visible, to make it almost invisible.
So you're not aware of the resources behind the hood that it's running on?
In a sense, so that's what I like about the cloud. In the invisible part is indeed, if you run a Jupyter notebook and you run it on your local laptop and it works on your sample data set, and then you log into the cloud and you get, and there is a virtual machine or a Docker container preferably, and that's all set up with exactly the same thing you're running on your local machine. Off you go. And then you could make that available to other researchers. So I think the advantage of the cloud would, for instance, be that we could create data processing pipelines. And these do not need to be unique to single research groups. So for instance, what we do a lot is text mining. Well, essentially, the text mining we do, some of the processing steps are the same for all of the data we use. So we could easily make that, and that's the visible part, visible to all of the other researchers. So if my hope for the Bear Cloud is that it makes some parts invisible to the end users and other parts really visible. So you can see, oh, there's actually other people that are also doing text mining. So maybe we should sit together, create one good pipeline, and then we would have so much more fun doing actual analysis.
You see this as then a tool for also almost facilitating interactions across research groups as well as being a fundamental part of being able to do your research.
Yes, and that is one side which we haven't talked about much today. That is the impact. The cloud can have a lot more impact than an HPC cluster. Because the cloud, you could put a web API in front of it, and you could easily create interfaces for even pupils in schools to work with. And you could make your data available to other research groups. You could interact. So that does require, as many have said, an investment in people. So people actually sit together and talk.
But I think that the tooling and the people will come through, because I think one clear distinction between the HPC world and the cloud world is HPC has been very much a world to itself. It's a fairly limited range of researchers in a fairly limited range of institutions, and there is very limited crossover, although you've been able to benefit from the availability of high-end Intel processors, high-end PowerPC processors. It's not exactly commercial off-the-shelf stuff in the large, and the tools which are used are very specialized, the skills are very specialized. A lot of the cloud stuff is being used for really nuts and bolts day-to-day computing. Small companies are moving their web servers into it. So the research community will benefit from those economies of scale, that there's simply more and more people working in the field, and the software is being developed by a much richer ecosystem of people. I mean, so for example, computer science has had virtually nothing to do with HPC for the last 20 years.
So how do we
It's
tighten
not
the
been
computer
on
science
our radar.
engagement with HPC? Because, I mean, that is going to be one of the critical parts going forward, and that's probably been one of the missing
We
areas.
don't, to be honest with you, we don't have problems in computer science which require HPC. We're happy to help people with their problems, but we you know, a lot of our problem. I did some fairly extensive simulation work for my PhD, but with theorem provers, but it was done on my laptop because I didn't need the capability. There's the apocryphal story in which Steve Jobs is supposed to have said to Seymour Cray, I've just bought a Cray to help design the next Apple. To which Cray is supposed to have responded, that's funny, I've just bought an Apple to help design the next Cray. You know, we don't necessarily have the same scale of problems.
But I think there's a set of skills that may be, I guess, for the end researcher, the information and understanding of the computers and the algorithms, but it's making sure that the computer science are recognised that they're supporting and developing that, because it's the people who write the codes don't necessarily get the credit. It's the people who are publishing the outputs and the results and data, and it's a challenge, I guess, across the whole of the UK globally. Have you got any thoughts about how best to start recognising those skills so that they're recognised? And Tony's smiling, so this sounds like it's something that you're trying to do with the EPCC outreach champions.
The research software engineer stuff is absolutely, we need to start recognising the fact that you can have a career in a UK academic institution without being the person that publishes the paper saying, I discovered that. You should be recognised for software development. It is a skill in its own right, and part of the problem we have is it is now really hard to do optimization of HPC codes, and you're moving even to cloud. Things are so diverse now. That is a skill in its own right. Expecting somebody who's specialized for 30 years in their specific thing, looking at the Zika virus, and we then expect them to become an expert in how to write hybrid codes? That's not something that we should be accepting. We should be saying the person writing the hybrid code needs to also have a career path. They need to be recognized. I don't know what the solution is. Is it publications? I don't know, but we do need to recognize that.
Well, I think you're going to struggle to recruit in the current economic climate to get high-end, high-skilled software engineers for the 35,000 quid a year that universities see fit to pay them. I think that's going to be a challenge.
That's not one we're going to solve today, sadly.
I think working in a university is a choice that you make. You know, some of us work in research computing because it's interesting for us, and I think that's the same across the university.
Yeah,
and if we
diversity of the
engage
challenge.
people who want to do it, and we've had students working with us this summer, and we're hopeful that they might be interested in taking forward some of these things, and we've got them sitting down in the audience that. You know, you choose to work in a university, and we choose to work in research computing and IT services here because it's interesting for us. So,
at the same time, it doesn't just...
So you get half your wages then?
I don't think he quite volunteered that one, sadly. So I guess it's an issue that is probably still going to be live, and one that we need to be looking at, maybe how we put the communities together to start challenging UK government's perception. It started with EPSRC, but we need to keep that traction going. So in a similar sort of fashion, in the panel's opinion then, obviously the way the universities are looking at total cost of ownership, what would you consider is a reasonable investment that the centre should be looking at targeting in the future when looking at local, traditional HPC machines, cloud infrastructure, either locally hosted cloud, and also what provision for external cloud or collaborations? And I guess probably Simon, with your experience around Climb.
So at Birmingham, we don't go after having the highest core counts. That's not something we're interested in doing. But we're interested in doing things which are, you know, useful and innovative for our researchers to help them to develop their research. I can't give you a value on how much we need to do that. I know how much we're invested. The university's investing in the life sciences. So that, that was a £2 million investment. We need to be looking at that, at least in another 4 years, a similar size investment. Though I noticed there's a question about Brexit on there.
Yeah, I was going to go on to that as my final question. A nice contentious one to finish with.
and that has its own challenges in pound sterling falling against the dollar, because everything's priced in dollars, and that's a big challenge for us moving forwards.
Do you monitor the total cost of ownership of the services here?
We don't have a figure on that. We want to look at how we do efficiency, so we're doing cooling, the right sort of cooling to go in there. So those compute systems we buy, they are more expensive than buying an air-cooled system, but it's a significantly lower cost to run them over the lifetime of the system. Now, unfortunately, the way the university works, maybe it's fortunate, is that power, we don't see a direct power bill necessarily. But actually we still want to be doing the things that are right in a sort of environmental terms and picking the right technology to support us.
Is there an argument, though, that for looking at the investment, both from obviously a Birmingham perspective, a UK perspective, that there needs to be a consensus set of frameworks put in place that looks at total cost of ownership, impact, KPIs and the monitoring, so you can assess when the systems need and sort of the pooling of knowledge? Is that something that the panel thinks would be a beneficial? Or too challenging?
My experience in industry at TCOs is you can use them to prove almost anything.
Like most stats.
And the endless toing and froing that you can make between capex and opex which is basic argument being made over cooling, which then drags in issues about lifetime, future projections on running costs and so on. I mean, I think broadly, the test is, are the academics and the research councils that are funding and supporting the work happy with what they're paying? And provided that actually doesn't have them basically wanting to sell the stuff for scrap on eBay and purchase something else with the proceeds, then I think that it essentially makes its own case. I think TCO calculations are very seductive, but often not terribly informative.
I think we need to... I agree, in the sense that we need to keep the R in bare, right? So this is about research. So if anything, we might try and measure what the impact is of bare cloud on research. So do we get more publications? Well, we don't have to measure the number of publications, but do we get better output? Do we get more impact? Do we get more researchers involved? Do we get more researchers from different genders, from different minority groups involved? Does this make the university's research thrive? I think that should, however difficult that is to measure.
At this moment in time, are those KPIs identified, measured and reported, and both from a Birmingham perspective for justifications for reinvestment in future, but also for a national sort of HPC, as you've identified, is a niche. Cloud is going to be coming in. How do we start forming partnerships as a sort of consortium across the UK to look at establishing a set of KPIs that would be understood the impact to help poll to UK governments about the importance of continuing the investment in sort of research computing?
I think that's difficult. I'm not sure you can KPI everything that you need to do. So Nick writes some code, for example, and then he posts it to Git, and then someone else takes it forward, and actually it can have a big impact, but we don't know about it because it might have gone to Cardiff or another university where they're taking that science forwards.
But by having a basis set, you're not going to capture everything.
No.
But I mean, if it's citations about when this code's being used, things like, there needs to be some baseline set at some point, I'd have thought, if we want to be demonstrating continued investment at this stage. But
There does, but I think again the point who said it, we have to remember the R in
Yeah.
research, that there is a, to my mind, rather lamentable tendency to regard university IT in general and research computing in specific as being kind of like running a payroll system, but a bit more so. And I spent too much of my time running payroll systems. It's a and that's Simon's point about it being a more interesting environment. It's a fundamentally different environment. I think we make bad mistakes when we start assuming that we can look at what's good for payroll systems and look at the structures and the KPIs and the SLAs that we would use for that and think that they dot straight across.
You never use those set, no, I completely agree. I think we need to come up with a unique set that we're looking specifically at research computing. Research is very different from enterprise IT, but in the interest of time, because I think they'll want us to wrap up in a few minutes because we are definitely at the end of the session. As you pointed out, Simon, there was a nice contentious question to leave the panel on the and that is, what do you think the impact of Brexit is going to be on HPC provision in the UK? And who have I got any? Simon's already started to touch on it, so maybe you want to start, and maybe the rest of the panel can then impact. You've already said about the currency fluctuation.
Yeah, I mean, I think the biggest risk for us as an infrastructure provider is, what happens with currency and how do we, if there's we're seeing an 18-20% difference in costing at the moment, and that's difficult to, we'd have no choice about that. There are no UK, manufacturers. Everything, Intel processors, everything that's coming in is dollar priced, and it's completely out of our control. And the university, hopefully understands that there's probably a bigger impact to IT organisations right across. I mean, every IT organisations are probably more impacted in universities than anybody else, I suspect. And I'm sure you find the same. You see the same risks in Cardiff that. The sort of cleaning services, catering services, there's a much lesser impact.
And maybe just to keep the people on the floor with the mics up, does either OCF, DDN or Mellanox wish to have any comment on the Brexit situation? Why are they all suddenly going pale and running for the doors? Oh, Julian at the back. Thank you, Julian.
I think I wrote a piece about it. And I think that good science will always get funded. I think that the dollar situation, if it stays constant now, will become the new norm, and you'll forget that you used to be able to get more. It's just a fact of life. It's something that, deal with it.
Are you going to give us a discount then, Julian?
Julian, he wants to know if there's any discount then for good reason.
More discount.
More discount.
More discount. You get a magnificent discount already.
Well, on that positive note, I'd like to thank the panel for their informative discussion and making my life as moderator extremely easy. So thank you ever so much. If anyone does have any questions, then they will all be available for the drinks reception afterwards. Once again, thank you very much for inviting me to the Blue Bear launch, and thank you, John.